You are listening to Within Tolerance, a podcast for machinists by a machinist. I'm your host, Dylan Jackson of Proteum Machining. And this week, I am very happy to welcome Brad Matheus. Welcome, Brad.
Hi, Dylan. Thanks for having me.
My pleasure. So for anybody who doesn't know who you are, what you do, what are all the details?
So I'm Brad. I run a company called The Factory Amsterdam. It was originally founded between me and a few friends from college, and we'll get into that later. It's just me now. I'm a machinist. Not originally by trade. I went to school for engineering and then design and a bunch of other things. Now I run a job shop. We make CNC turned parts. We make SLS printed parts. And yeah, that's about it for now.
Awesome.
Yeah.
Let's get into your backstory then. How did you get to where you are today?
So I guess going way back, I've always been interested in making things. That's ever since I was a kid. Started with Legos and then going on to tinkering in the garage with my dad's tools when I was a real little kid. Got into modifying Nerf guns at a very young age when I was like 10. Started doing robotics and stuff. This is a real high level overview kind of thing. Got into first robotics in high school where we had a machine shop. So we had a couple Haas mills and lathes in there. So some TM1s, TL1s. Those were the first CNC machines I ever ran.
In school, you had access to those.
Yeah. So I started machining on like actual machinery when I was like 14.
Cool.
Yeah.
Oh, man. I wish I had access to that. I didn't even know what any of this was really at that point.
Yeah. So to take it another step back, I bought a Harbor Freight lathe when I was 13 because I wanted to make parts for Nerf guns because most of those parts are round. So from there, I messed around with that in my garage a little bit. Went from there into high school, and then because I already had a little bit of machining experience just from tinkering, they let me play with the nice tools pretty early on, a little bit earlier than I'd normally get access to them kind of thing. And then during the summers there, they had a partner program with one of the local community colleges, Compton College, and they didn't really have a great shop there at the time. It was a bunch of Bridgeports, some engine lathes, and then some real old CNC stuff. There was a Bridgeport Interact 412 VMC in the back that no one had touched. It was from like 1985, had a Fanuc O-mate on it.
Oh, that's nice. At least it was a Fanuc. I know I've seen some Bridgeport mills with like their weird DOS interface.
Yeah.
And that's a nightmare.
Yep.
So at least it had a Fanuc.
Yeah. The O-mate was interesting. It was the OMA, I believe. So it was an 8-bit control. No storage on board of any kind. Like if the program was bigger than a couple kilobytes kind of thing, you had to drip feed it. So learned how to use DNC real early on. Had to troubleshoot a whole bunch of issues with those old machines. And the nice thing was because the program at that community college wasn't super well developed at the time, they had a couple rounds of bad professors running things who weren't really that invested in the school. I got to kind of play. So the reason I was taking those classes was to get access to a mill because I didn't have one at home and I couldn't use the ones at school in the summer. So I would do my personal projects there in addition to the class stuff. And then I kept going back every summer and eventually started working there just as like a part-time kind of thing as an assistant to the professor that I worked with. And from there, I helped them develop a little bit of their CNC program. They got a TM1P while I was there. That was in 2012, I believe. And then also a TL1 because that was kind of the standard package Haas was doing for schools at the time. So I actually took the first round of students through the TM1 there, which was kind of neat.
Oh, that's super cool.
Yeah, it was a really cool experience. During the summers, they only did the 101 course. So it was the NIMS drill press level 1 was the project that you did for the class. And there was a group of students there that had already gone through that 101 course earlier, and they were a little bit more advanced and they wanted to learn a little bit of CNC stuff. So the professor had me kind of teaching them on the side while the rest of the class did the manual stuff. And that was a really good experience for me. I almost went into teaching after that, or at least we had talked about it for a little bit because the professor I was working with was looking to retire at some point, needed someone to take over, but then there was some politics in the school and that didn't happen.
Yeah, it can get a little dicey. I know at some point I interviewed for a position at the U of A here as a shop tech or whatever. And in the interview, they were like, yeah, so like, a big part of your job is just like preventing engineers from putting end mills and drill chucks. And I was like, I don't think this is right for me. I appreciate it.
Yeah. I've done a little bit of that when I was in college too. So I went to RPI, Rensselaer Polytechnic Institute, and I went in as an engineering major for mechanical engineering. Quickly learned that I did not want to be doing that. But in the meantime, I kind of got involved in the manufacturing department there because it was very small. There were, a half dozen, maybe a dozen professors in the whole department kind of thing. And not that many students went down that track. It was mostly technical electives and stuff that not a lot of people even had time for. But they had one course called MPS. It was Manufacturing Processes and Systems. And it was a 2-semester series where in the fall, you got with a team of about 15 people and you had to design a product to be manufactured. So they wanted you to use as many different processes as possible, at least that we had access to on campus. So there was injection molding, machining, water jet, sheet metal forming, robotic assembly, and I think a couple other things. So pretty comprehensive.
That's
And
killer, man.
yeah,
That I feel like all engineers actually need that course.
they do. And I really wish more people would take it. I wish they would make it more available. But then the second semester series, they picked 2 of the projects. So there's 4 teams in the first semester. They narrow it down to 2. And then everyone who wasn't on one of the teams they picked gets added. So your teams wind up around 30 people. And you have to make 400 of that object in a semester.
Oh, wow. So not only are they like theoretically saying design this for manufacture, they're like, well, it better be designed for manufacture or you're going to hurt for 400 pieces. I love that. Oh, man.
Yep. So that was quite the learning experience. I'd never made an injection mold at that point, and I made the injection mold because I was the only one with CNC experience. So I knew Mastercam at that point because we learned it in high school, and that's what RPI used as well. I think I had a newer copy of it on my computer than the school did, in fact. But all we had at the time in that lab was a 1999 VF1 with an umbrella changer and very limited capabilities. And we managed to design and make the most complex mold that class has ever seen. They still use it as a demo to this day. I think there were 32 or 34 individual inserts that were swappable for different features. So there were like right and left sides of different components. So you could swap in the part that had text and the part that didn't have text. There was a slide that relieved some text on the side of a big round base. The product was a little snow globe looking thing that had the hockey team mascot called Puckman. It's a hockey puck with a hockey stick. So we formed the little hard hat that went on his head. We had these little water jet cut sheet metal blanks for the hockey stick. And I made a little die that fit into the injection mold so it would bend the curve on the stick as the mold closed and then shoot plastic around it so it was over molded into Puckman's hand.
Holy, how cool.
Yeah, it was really fun. And then we got these little music boxes off of AliExpress programmed with the RPI fight song and everything, put them in the basic, press the button, it would play it. We had a vacuum formed dome over the top.
Wow. Yeah. So you guys really
cool
overperformed. I'm sure they were like, what are you guys doing?
Yep. Yeah, it was great. Had a great time doing that. But yeah, so at the same time in college, there were a couple other shop classes. There was one that everyone had to take just with the manual machine. So I would go in and TA for those sometimes. I would help run the engineering labs for a couple different classes that had more hands-on focused projects. But most of the classes at RPI were not hands-on oriented. You had to kind of find that. And I learned later on that there's actually 2 types of engineering schools. And RPI is one of the ones that trains you to go into management. And they don't tell you that. And apparently it used to be different there. I mean, at one point we had the leading aerospace composites program in the whole country. They had these huge layup tables. There's actually a sailplane that was built by professors. It's all carbon fiber. And it was hanging in the dining hall, at least when I was there. And they actually flew it. They built 2 of them and flew them. And that was back in like the 80s or something when composites were bleeding edge technology. Like not many schools were doing that. And then, of course, they got rid of it.
Right. Yeah.
As you do.
Yeah. I think that I wish that more engineering schools were upfront with that, with what kind of engineering you were, or at least like gave you some tracks to follow.
Definitely.
Because, I mean, I guess thankfully in my case, like that's kind of how the U of A came across, at least in the first couple years. And that's what steered me into manufacturing. So like, I guess I'm very thankful in retrospect looking at that, but like would have been nice going into it. Like, hey, you're a hands-on guy and you're going to get none of that here. It was like, oh, yep. Okay. Yeah. So
Yeah, I did get a lot out of RPI because there's a bunch of really smart people there, and you're always going to have nerds who want to build stuff at an engineering school. Whether or not you give them the resources to do it, they're going to figure it out. So on campus, we had the RPI Student Auto Shop. It was an entirely student-run club that really had no oversight from anyone. They got shut down at one point because everyone was building monster trucks. And the idea was it was supposed to be a campus resource for students to learn how to do basic repairs on their cars. And of course, if you give a bunch of bored engineers a shop space and tools and a lift and everything, what do you think they're going to do?
Right, exactly. Yeah. Well, that's the craziest thing we could make.
Right. Monster trucks, obviously, which, pretty sweet. I've seen pictures from that era. It was awesome. It was actually in an old tank shop, too, because the building it's called the Armory. And it was the armory for the U.S. military in this area in like the late 1800s, early 1900s, something like that.
So cool.
Yeah, a lot of history in this area. But yeah, so I actually started the shop because of the RPI Student Auto Shop. We were building cars there. My buddy Kevin was building an 800 horsepower Chevy Caprice.
Awesome.
Yep. And the school didn't like that very much. I don't know why. They just weren't fans of what we were doing.
I'm shocked, personally.
Yeah. And one summer we were working in there, and the professor who was in charge of overseeing our shop space came in, and he was like, What are you guys doing? This shop is full of project cars right now. There's no room for anyone to come in and do anything. You need to stop. So we're like, all right, fine. Started looking for shop space in the area. Found a spot up in Amsterdam, which was about 45 minutes from where I was in Troy. But it was cheap, like dirt cheap. We're talking 10 cents a square foot a month kind of thing.
Whoa.
Yeah.
That's unheard of.
Yep. It was an old mill building. Amsterdam's a sleepy little town on the Mohawk River, which is the Erie Canal. So it was at one point a huge hub of industry, but everything left. It was a carpet mill town. There was a lot of leather goods produced there. The building we were in was formerly the Founds Leather Glove Company. They moved somewhere else, I guess. But it was a 6-story building. Each floor was about 20,000 square feet. And it was built in the early 1900s. So it had all of the problems of a building built in the early 1900s. The only way in and out was 8,000 pound capacity freight elevator. Or stairs, but
right.
Wants to climb 6 flights of stairs every day. And that really limited what we could put in there, but it was big enough to fit cars in. And that's what we really needed to get started, because we needed a shop space where we could put all of our car projects that wouldn't piss off the school too much.
Right. The idea of, sticking car projects on the 6th floor of anything, though, is like so foreign to me. I mean,
yep.
Like Arizona, more or less, but Tucson especially, like we don't have that many tall buildings, period. Everything goes out. And so just like the idea of like, oh yeah, I work on cars on the 6th floor of a building is so foreign.
Well, then put a machine shop up there.
Right. Yeah. We haven't even gotten to the part that's extremely foreign.
Yep. So our cars were up there working in there, and we got talking, and we're like, hey, maybe we can make a little bit of money doing this stuff. I'm like, I know machining things. I hadn't really worked in many shops at that point. I did a co-op, a 6-month internship at Sikorsky, actually, as a manufacturing engineer there. That was a great experience, and that's really what turned me off of engineering, was because I was working a desk job there, and it really sucked. Everyone there was like my parents' age or older kind of thing, so I couldn't really relate to my coworkers that well. I was 20.
Yeah.
So a lot of downtime there. They didn't really know what to do with me, because like I knew how to program things, but I didn't know how to use CATIA V5 to program things, which was also not fun. But I got to see some really cool stuff.
Oh, I bet. Yeah.
Yeah. So came back to school, had a couple really rough semesters, decided to start the shop, changed my major to design in my senior year. And as all of this is, so the major change and starting the shop happened at the same time, which was,
oh, geez.
Yep, it was a lot. So we started the machining side of things because we're like, look, we don't want to be paying rent out of pocket kind of thing. Maybe we can make enough cash to make this viable. Bought a Grizzly bench mill, a Geo 704, converted it to CNC, hated every minute of using it. Was running off a Linux CNC with Chinese servos and Mesa cards, which is kind of a weird combination.
Yeah.
It at one point snapped the Z-axis ball screw because the angular contact bearing supporting it, the preload nut loosened up, and it seized, just sheared the motor connection straight off. The head dropped into my part while I was running, and I'm like, screw this.
Oh, no.
I am done running this machine. So we're like, all right, we need to get a real machine if we want to actually make money doing machining, because we'd made a few $100. I mean, we were splitting rent, so it was like $200 a person kind of thing for our little corner of the floor. Not really the end of the world, but we wanted to grow a little bit beyond that. So we're like, hey, how about Haas? So I called up the local dealer who I'd actually met at the school before because they were a sponsor. And they're like, all right, how about a mini mill? So we got a super mini mill. Because, we'd done a few jobs at that point, kind of proved out our ability to deliver parts to people, and it demonstrated that there was money to be made. So a few months went by of hating the Grizzly. The mini mill shows up. And then we're a real machine shop all of a sudden. Didn't really have a lot of customers lined up for that, which was kind of an interesting decision. But, mini mill's not crazy expensive to keep up with payments on, right, especially split 3 or 4 ways kind of thing. So we were kind of limping along, and then one of my buddies had just graduated, and he started work with Formlabs, actually, and he was an engineer there.
So I was wondering where the connection would be made there. Okay.
Yep. So he was an engineer, needed to do a lot of prototyping work. It was all quick turn stuff. They were in the middle of a development cycle. Everything slammed. All of their suppliers were backed up, whatever. So he's like, hey, I'll send you some work. So we were doing like 3-day turnaround jobs kind of thing. There was one time they called me on Thursday afternoon. They're like, hey, can you get these parts to us by Monday? I'm like, okay. And they're like, yeah, it's a blank check. Just do what you need. I'm like, all right.
Yep.
I'll do it. And sure enough, they had parts in hand by Monday. Worked all weekend to do that. A lot of all-nighters at that point in time because, still being in school, all-nighters were a little more manageable. Like, I can't do that anymore, my God. But yeah. So started doing work for Formlabs. That brought some real money in. Still have that relationship a little bit, but they're
awesome.
They're kind of doing things differently now. So, yeah. At the same time, our Haas dealer knew that I needed money because we're broke college kids trying to start a machine shop. So he's like, hey, one of our other customers is looking for some programming work to be done, looking to hire a contractor kind of thing. They're right over in Troy where you live, and they were 5 minutes from me. So it was perfect. Started doing about 20, 25 hours a week for them while I was still in school. So,
oh boy.
Yeah.
Okay.
So at this point in time, I have a mini mill. I'm in my, what was that? Would have been my 5th year of college? 6th year of college. My final semester. And I'm working 25 hours a week, taking classes, and then also working at my own shop. And this is killing me.
Bet. Oh my goodness.
A year prior, I had been diagnosed with Crohn's disease. So that made things even more interesting. Oh. Because of the stress of school and the things that I was doing to myself, I presume, is what caused that. So, yeah, I was not in good health at this point. And I just hit the end of the semester, basically skidded to the end of it kind of thing, just barely straight by, graduated. I'm like, okay, I'm done with that now. My contracting gig was going all right. I could tell work was slowing down there a bit. Then they get a job making these cable hanger brackets for some government entity. And it's these rectangular plates that are steel, like A36 or some garbage hot roll material. They're like 2-inch wide by maybe 6 inches long, have 2 holes through them. They're 5/8 with a 1-inch countersink. And I have a mini mill. And they're like, we don't have the manpower to do this the way we can think to do it kind of thing, because they weren't set up for any kind of production work. They're mostly a fab shop. So a lot of the programming work I was doing was just like punch a couple holes here, mill a slot in this piece of square tubing kind of thing. That was about as advanced as they got. Their Haas mills were the scariest I'd ever seen. They had a VF6 and a VF7, both 50 taper. Each one had between 3 and 5 thou of backlash in the X and Y axes. They needed a new spindle on the 7 6 months after they bought it. They're model year 2008 machines. So 6 months after they purchased it, they needed a new spindle because one of the operators filled the spindle lubricant reservoir with coolant.
No.
Yep.
Oh, no. I was like, preparing myself for some terrible crash story because I was like, to break a 50 taper, that's got to be a beefy, crash. But no, you
Turns
just
out you don't have
build
to
around.
crash it.
Yeah. Wow. Oh my
Mhm.
goodness.
Oh, yeah. So that kind of gives you an idea of their approach to maintenance and everything that they do. I don't know how they make money, but they do. They're big enough that they can do that. They've got probably 50, 60 employees there, kind of thing, mostly welders. They do a lot of sheet metal stuff, laser stuff, and the machine shop's kind of neglected. So the kinds of programming I was doing there was probably not what they should have hired me for, kind of thing, because they were paying me way too much to do that kind of work.
Right.
But
Yeah.
yeah, so there was a little bit of tension there between management and me, I think. They didn't like how much they were paying me, but they had agreed to it. And so then they decided, hey, well, we'll sub out this work. So I claimed to be better suited to do it than they were, and they believed me. And they needed 7,000 of these parts in 3 weeks. They had been talking to me about this for a few months. They told me, oh, no, the job, we don't know what's happening with it. It might not happen. It might happen. Then they're like, oh, we need these 3 weeks from now. I'm like, okay.
Oh, man.
They told me a price. They supplied the material. I agreed to do it. We cranked out 7,000 of those parts with 3 people in 3 weeks.
On one machine.
On one machine. I got that cycle down to 26 seconds, I believe.
Oh,
we were
wow.
running one part at a time. I had a single station vise, hand loading every single one.
Oh,
we would
geez.
rotate 3 people. One person would be sitting at the mill loading parts. One person would be manning the shopping cart to move them over to the tumbler. And one person would be taking them from the tumbler to the rinse station to the oven to dry them off, because we were getting splash dust problems.
I feel like every shop has that early job, though, that just sucks. Like our first big customer was a local customer that did stamping.
Oh,
okay. I think it was for like private aircraft panels and stuff like that.
Mm-hmm.
And so we would take them from them and then put like tight tolerance holes or counterbores or something in them. And there was more time into screwing down like 10 440s into their fixture than there was actually running each part. And I mean, I've got like time-lapse videos of me and Brad just like trading off for 6 or 10 hours or whatever, just doing hundreds of these, because they were a super quick turnaround too. They'd be like, hey, we've got 100 of these for you to pick up. We need them tomorrow.
Of course.
Like, cool. Okay. So after work, we'll come and grab them, and then I'll work all night to have these done. Awesome. But yeah, it's another one of those like, man, that thing really sucked, but it made our company. And, I wouldn't do it again, but
yeah.
but it helped at the time.
Yeah, it was what we needed. I mean, we needed money at that point, and that was money. 7,000 of anything is money.
Right.
But yeah, so unfortunately, that kind of put the nail in the coffin for that relationship with my employer / customer kind of thing.
Oh no.
Because their management was very egotistical. Their main problem there was the workplace culture. It was not a good place to work. I found out later they had an average 3-month turnaround on employees at one point.
Whoa.
Yeah. Really bad.
Wow. That's terrible.
They're known as one of the worst shops to work for in this area, as I'm sure you can imagine. And the management there is super cliquey and weird about things. And specifically, the VP of operations did not like me. And we were trying to get communication from them on something, and they were not returning my calls. And eventually I was like, look, I'm not doing anything else until we all sit down in a meeting and get on the same page here. And that got me a response. I'm like, I'm not delivering any more of these until you tell me what's happening. Then the VP of operations called up my business partner and screamed at him over the phone.
Really?
And that evening, I wrote a long email to the owner of the company, and I'm like, I can't work for you anymore. I explained everything that happened. And the next morning, when we called them, we got the VP of operations again, and she was super nice and friendly to my business partner. And she was like, oh, thank you guys so much for getting these done.
Ooh. Yeah, that would make my blood boil.
Yeah. So that was not a great relationship. But, it's what it
started
is.
Your company. Yeah.
Right.
It was a big order and all that stuff. So.
Yep. So at that point, we were doing lots of job shop work. At the same time, we were also doing powder coating stuff because I had a powder coating gun, just one of the Harbor Freight ones that I was using to finish some parts actually for Nerf guns.
All roads lead to Nerf.
It's seriously, we'll keep coming back to that quite a bit. And I was just using it with a toaster oven in my mom's garage. I brought it actually out to college to finish some parts in my dorm room with a little like 2-gallon compressor kind of thing. But it was nice because it was cleaner than paint. It was a lot easier than paint. You didn't have to worry about mixing and solvents and all that shit. And it's a pretty easy process to get into. To get really good at it, it takes a lot of skill. You do need nicer equipment than a Harbor Freight gun eventually. But, it's pretty approachable, I think. So I was like, hey, why don't we start doing this on the side for extra income? It's really easy. We know all the automotive people in this area. They all want really nice finishes on things, and there's not a lot of powder coating around here. There's one big shop likes doing race car parts, and that's it. Even though they take on a lot of commercial work, they have a big conveyor fed oven and everything, probably 30 guys there. But they have a reputation for not delivering your parts in any reasonable time frame. Like, it'll take 6 months to get them back kind of thing.
Oh,
if it's not someone they like and it's not a project they're interested in.
Right.
So if you're doing a tube frame chassis for a dirt track car kind of thing, there's a lot of that out here. Oh, you'll get it back in a couple weeks. But if you've got, 100 railings or whatever for some commercial project, you're never going to see those again. Right. So we started taking on smaller jobs. We had a couple of kitchen ovens that we got for free that we were using for powder coating rims and stuff.
Nice.
We upgraded the Harbor Freight gun to a Redline Easy 50, which is a little cup gun. It's got a slightly nicer power source on it and everything. Big step up from the $70 Harbor Freight unit. We're using that for a while. We found a bigger oven, which I still have actually. It's 5 by 5 by 8 feet tall. It's electric. Worked really well. And I was having my business partners do that kind of stuff while I did the machining because I had the machining background. They needed something to do, and that was a good use of their time. So that kind of split the business a little bit. We were doing about 50% machining, 50% powder coating. And it's kind of weird to be growing a business with no money in two directions like that. In fact, it's a bad idea. I came to learn later. So fast forward a little bit, we're taking on jobs and stuff, getting into bigger and bigger powder coating projects, bigger and bigger machining projects. Landlord sells the building out from under us. Great. That was 2 years into the company, I believe, 2.5 maybe. Not fun.
Oh boy.
Yep. So fortunately, one of the old tenants of the building, there were multiple businesses in this place, owned a spot around the corner from us. And he was like, hey, I'll lease you guys the 5th floor of our building. We've got an 11,000 pound freight elevator, a little bit bigger, a little bit longer.
Nice.
Yeah, upgrades. A lot more power, a little bit more modern building. I think it was built in like 1920. Much beefier though. The floor loading was something like 400 pounds per square foot, which is crazy. It was 18 inches of concrete on the 5th floor kind of thing, supported by these columns. The big columns that had vents running through them were like, I want to say 8 feet in diameter. They were huge.
Jeez.
Yeah, big place. At one point, the DoD used it for something during the Cold War. It has a missile bunker in the basement, which is pretty cool. Yeah. Unfortunately, the roof leaked.
Oh.
And again, this is a huge building. Our side of the floor, it was split in two, was 20,000 square feet as well. And we were renting the whole space. Space is cheap out here.
Apparently, I'm like sitting here watering at the mouth for 20,000 square. That's insane.
Yep. But, we were the top floor. The roof leak. That's a problem for us, not for the landlord, because he had his business running downstairs. He ran a cabinetry shop for doing big commercial installations for like hotels and office buildings and things like that. By the time we left, he'd built out a fully automated second floor that had a gantry loader for these huge 5-axis routers that would load full sheets of plywood in and parts would come out. He had an automated trim production line that would actually grind the cutters on these big HSK shanks and install them in the machine. It would run the boards through it and everything and would cut custom trim profiles for these crazy high-end installs. Really impressive operation. But because roof was not actively leaking on his stuff, he didn't care to fix it. He had someone come take a look at it and they were like, yeah, this is going to be at least $1 million project.
Oh.
It was an old tar roof. And I guess it just hadn't been maintained in like decades. So the OSB underneath the tar paper and everything had swollen over the years, and it had taken on so much water, it was like inches thick. It was disgusting. You walk around up there, the whole thing's like squishing around and everything. And of course, underneath it, the ceiling was concrete and probably about a foot thick. So over multiple freeze thaw cycles in the winter and everything, the water had whipped its way in there and opened up cracks. And we would get like stalactites growing out of the ceiling of weird kind of brownish yellow goop kind of thing. Oh yeah, we'd have water drips all over the place, and we can only really use about half the available floor space, or because of the way we had to lay things out, it wasted so much space in that building. And that made, powder coating difficult because you don't want water dripping on your parts while they're powder coating, obviously.
Yeah. I mean, powder really in general doesn't like moisture. So
no, it doesn't. Yeah. So we had buckets all over the place. We'd be finding new leaks all the time. And we're like, all right, this is a problem. We had a 3-year lease there, and we were growing more and more. We had an even bigger powder coating oven. It was the biggest one we had was 15 feet long by 8 by 8 feet. So we were doing full car frames. We were doing huge railings for like architectural stuff. We were doing semiconductor machine bases for the new Global Foundries facility they're building, which is pretty cool, like 5,000 really pound weldments. So the elevator became a big problem when we were doing this stuff, being on the 5th floor, because 11,000 pound capacity, but that fills up pretty quick, especially if you need any kind of material handling equipment in there. So we couldn't have the forklift in the elevator with the machine base at the same time. So you'd have to forklift it in, bring it up, somehow get it out of there, and then come back down, get the forklift again, bring it back upstairs. Or use the downstairs forklift, which couldn't go in the elevator, to unload into the elevator and then catch it upstairs. It was a nightmare. It would take like an hour to bring a part into the building, kind of a thing, if it was a big structure like that.
Oh, geez.
So that got real old, and we were looking for new spaces this whole time. We had probably 5 or 6 buildings we were looking at in the area, all really big, really old mill buildings, because that was what was available around us. The first one we were looking at was being used as a Buddhist monastery by this group of monks the town of Amsterdam did not like, because I don't think they paid their property taxes or something. It was odd. And the town was under the impression that they were just letting the monks use it, that they didn't actually own it. But then we got shown around the building and everything, and came to find out later that no, the monks did own it and they weren't looking to sell.
What?
Bizarre. Yep. And then we were looking at another place around the corner. We tried doing the SBA route, which you've heard a million times, never works. I was hearing those episodes of the podcast at the time we were doing this stuff, and I was telling my business partners, I'm like, everyone else is having a lot of trouble with this. You think we should look for a plan B? They're like, no, these guys say it'll be fine. And it was not fine. No. The environmental assessment was the problem. As with every single real estate purchase for commercial real estate, I guess, it's always the environmental assessment, especially with these old buildings. This one we were looking at was on 5 acres. The lady wanted, I think, $120,000 for it or something, because it was falling apart. Yeah. Mm-hmm. Was falling apart. I think combined it was probably 160,000 square feet between multiple structures. It had an old bank vault from the late 1800s in it, because that was the company bank.
Cool.
It was amazing. I mean, half of it was falling apart because it hadn't been maintained in forever. But then they came and did the environmental assessment, found 5 buried tanks with unknown contents, pulled up old records from, pulled up old records from the DEC, basically the New York EPA, from the early 2000s, when a previous tenant there had apparently been doing some automotive stuff, and they were just painting cars outside in the grass. There were pictures in the report.
Oh, no. So literally like worst case scenario for one of those reports, like tanks with weird stuff plus paint plus.
Oh, yeah. Mm-hmm. And in the 1940s, the hill that it was on in Amsterdam was manufactured. It was not originally there. They built it by knocking down an old parking garage or something downtown, bringing those blocks of concrete up the hill and using them as ground fill. They also threw a bunch of old appliances in there, because that's what you do in the 1940s, I guess, because obviously there can be no problems.
It's not a problem if you can't see it.
Right.
Yeah.
Well, there's a little stream that runs past the building with a waterfall and everything. And you'll notice that it runs perfectly clear, like crystal clear. And, the Mohawk and the Hudson River are not known for being particularly clean, but this little tributary to it is. And that's because of all the old refrigerants that are leaching into it.
No.
Yeah. And there's nothing you can do about that.
No. You're not going to you can't tear down the hill. Like,
no. So that was a disaster. There was another building a few towns over that we were looking at that they had another buyer who was kind of waffling on it, but had managed to convince the sibling. It was like a family was selling it. So some of the siblings wanted to go with one buyer. The other ones wanted to go with us, kind of thing. And we weren't able to get it. And that was what happened last September when we decided to split. So right around IMTS last year, we were in the final talks with that family about buying the building. Basically the day we got back, they called us. They're like, "Look, we can't sell this to you." We're like, "Cool." We were just at the show. Man. We were looking at all this stuff. We had all these plans. We had 3 months left in our lease at that point and nowhere to go. And because of the scale of our operations, at that point, we had multiple employees. So it was 4 of us partners by then. We'd brought on a 4th guy and 2 full-timers and 3 interns and a grad student, I believe. So 10 people total. Pretty good size crew in 20,000 square feet doing these big, big things. You can't just up and move that very quickly. So we're like, well, we either stop or that's really all we can do. So we had a discussion. We're like, look, I think this is kind of a natural end. And I'm kind of thinking to myself, I'm not done. These guys are done because a couple jobs fell through at the same time. We were doing these powder coated bus bars in huge volumes, like, 1,000 a month or more kind of thing, with super complex masking where they had called out position tolerances on the masked features of 30 thou kind of thing. So you have to place these tape shapes around the features, sometimes just in arbitrary spots on this complex bus bar in 3 dimensions kind of thing, and then peel them off perfectly. They needed all the edges to be perfect. And even better, some of them were plated. And the ones that were plated, some of those were tin plated. And you know what the melting point of tin is?
Is it lower than powder coat?
Yes, it is. So they're like, we're getting all these failures. The powder coat's flaking off. What's going on, guys? You're screwing all this up. And we're looking at it. They're like, we're baking these at, 425, 450 degrees for this special electrical insulative powder coat that they wanted. And they needed a super thick buildup for some reason because they weigh over spectrums like 12 mils or something, which is a lot for powder coat.
Oh, wow.
Yeah. So peeling off the masking on that was not fun either. You really had to sit there with a knife and cut out each little shape, and miserable. Yes. So that didn't work. And they're like, we haven't been able to get anyone to do these. Wonder why.
Yeah. They're not possible. That's why.
Right. So that kind of burnt us.
Before we move on, when did you guys start down the 3D printing route as well?
Oh,
were you doing that at this point as well?
Yes. So when we first got the fuses, that was end of 2021. So like December 2021 is when I got the first fuse. And at the time, they only had the fuse 1 out. Now I have a 1 plus as well. So we were doing a job for a toy company that involved a lot of prototyping. So it was more of a design oriented thing. And it was a long-term project, went on for about 6 months. And that was mostly on my end. So at the time I had a couple of Form 2s that I'd borrowed from my friend who used to work at Formlabs because he built them out of dumpster parts kind of thing. And it's pretty cool.
Yeah, that's awesome.
So I had a space to put them and he was letting me use them in that space kind of thing. And I don't really like resin printing. It's so messy and sticky, and the parts look nice, but they're not very functional. And I needed functional parts. So I'm like, well, this job's paying enough for it. We might as well get the right printer for the job. So we got a fuse. And at this point, I had made a whole bunch of calibration equipment for the fuse. So I knew exactly what went into it. I knew how they were built.
That's super cool.
Yeah. So I was pretty confident in how well it would work out for us. And it did. I mean, the fuses have been amazing for me. They're very, very reliable. That first one that I bought now has 5,000 or 6,000 hours on it in its head, like a stepper motor fail.
That's killer.
I replaced. Yeah. Very, very reliable machines. So yeah, 2021, we got the first fuse. We're using that for that design job. And then we were like, hey, let's do a little bit of production with it. So as a test case, we built some Nerf guns, as we do.
Okay, yeah.
So
It's Nerf for nothing.
Right. For perspective, I've been selling parts for Nerf blasters since I was like 13 years old. That's been kind of a consistent theme in my life. I was making them on that little Harbor Freight lathe in my mom's garage for all of high school. And then when we started the shop, that was what I used as filler work on the machines anytime we had some downtime. Because it is good, side income. I don't think I would want to make that my main business focus right now, but it's a really good way to test out new processes in the shop on things that are pretty low stakes compared to like a customer job that needs to be delivered in 2 weeks. This way we can sit down and really characterize the machines, figure out what they like and don't like. Orientation's a big thing in SLS printing. So we were able to figure out what the fuses are expecting and how they work best. Ran off a bunch of those, sold them. It was pretty fun. Then one of our other customers, who's a blacksmith on the side, he was actually on Forged in Fire at one point, which is kind of neat. Yeah, he has a little fab shop, blacksmithing, welding shop kind of thing up in Amsterdam. He's an engineer at another local company who's now one of my bigger customers. And he's like, hey, we're doing stuff with hydrogen. It turns out nylon 12 is one of the magic materials for working with hydrogen because it doesn't off-gas into it. So, at least that's what I was told. They had these injection molded parts that they were having made in China, and everything was backed up. I mean, this was, COVID was pretty much over at this point. This was 2022, summer 2022 kind of thing. But supply chains were still pretty messed up. They didn't know when these parts were going to arrive, and they needed a few thousand of them. So they had me print them, and I was running that printer as much as I physically could. I think I hit 600 hours on it 1 month.
Wow.
Yeah. So
That's
it was
awesome.
Me and one other guy kind of tag teaming it. He would come in early and then I would change it over if it finished towards the end of the day kind of thing. And we would almost never have more than like 4 or 5 hours of downtime on it.
That's cool. So
in any given day.
For anybody who's listening who isn't familiar with the process, I mean, it's a laser-based sintering system, but what goes into actually prepping and printing and post-processing?
So Formlabs makes it really easy, and they make it a lot easier than a lot of other SLS printers do, from what I can tell. I don't have a lot of experience with other brands of printers at this point. I'd like to get into that in the future. But Preform, their slicing software, has some magic math built into it that does a really good job of compensating for warpage and any other dimensional inaccuracies that you can get during the print process. Because normally you'd have to sit down and dial in your settings for the laser power and speed and all that stuff manually and do a bunch of trial and error to figure it out. And the other manufacturers give you profiles to start with and stuff like that. Formlabs doesn't let you touch any of that. It's just all behind the scenes, all baked in. And I like that on a machine that I bought to make money with. If it's a project, I want to be able to screw around with it. This, I don't want to screw around with it. I have the 3-year warranty on it. That's, if anything breaks, they come fix it, and it's not my problem.
Right.
Which
that's
exactly
super important.
I want it. Yeah.
Yeah, exactly.
And, I've heard people complain about, not being able to change the settings on the printers. And I'm like, I shouldn't have to in the first place. That's kind of my approach. So I use Materialize Magics for packing, which actually costs more than the printer. It's a high-end additive software package that does all kinds of things. You can actually use it as a slicer for other printers. It can do FDM, SLA, SLS, DMLS, pretty much any process. And I bought it specifically for nesting because in SLS printing, your packing density is the most important thing. You have to keep that density up or you're going to be wasting powder. Formlabs, they recommend about a 30% refresh rate on the powder. So it's 30% fresh powder going into 70% reclaim. It's pretty easy to get that going so that you never have any waste if you pack the chambers reasonably efficiently. I haven't thrown out powder in 2 years, I want to say, or I guess as long as I've had the printers, I've never really had to throw any out.
And with the cost of those powders, I mean, that pays for the software pretty quick, I would imagine.
Right. $100 a kilogram, adds up.
Yeah. How much is a entire build volume of powder weigh?
It's about 6 kilos. It really depends on the packing density as well, because sintered powder takes up less space than loose powder, of course.
Right.
So I find that I can typically get a little over a kilogram worth of parts in a build chamber reliably. Densest build I've ever packed, I think, had 1.4 kilos of cindered powder in it, which is a lot considering it holds 6 total. Yeah. So workflow wise, I mean, I dump all the parts into Magix. I hit like 2 buttons and it packs them for me. It's great. I export that as an STL, and this is the stuff that's kind of annoying. And then I dump that into preform and tell it to print it. Wish there was a connector that between the two, and I think they're working on it. I was talking to them at one point, but it's not there yet. And then once it's in preform, I mean, you literally just click print and it works. I very rarely get build failures with it that weren't my fault. The most common reason for a build failure I've had is forgetting to put enough powder in the machine, because you can't pause a print on those. And that was something that was kind of new to me. I've never had a printer that you could not pause.
Oh, that's interesting. I didn't realize that.
Yeah, the whole thing's heated up to about 400 degrees, which is it's just under the glass transition point in nylon.
So right, it's just the laser's just taking it right over the edge.
Exactly. Yeah. So if you hold it there for too long, you get degradation in the powder. The particle size starts to increase because they clump together a little bit. You get weird defects and things. And you also don't want to cool it all the way down, because everything's going to shrink and you'll have even more problems if you try to start up halfway through a build. It's really, really particular about the environment that it's printing in, basically. So yeah, if you don't put enough powder in, then it's going to fail. Funny how that works.
Yeah.
Once the print's done on the Fuse one, it takes a little over 30 hours for a full build. And that's pretty consistent regardless of how many parts you have in there. The longest build I've had, I think, was about 35 hours, and the shortest full build, like full height, was probably like 28 or so. So not terrible. The Fuse One Plus runs twice as fast, so I can run a full build in 18 hours, that's crazy. Awesome. And the way they do the cooldown, you don't have to wait 12, 18 hours like you do for MJF, where it runs super, super hot. And MJF has a much higher productivity than SLS. It's a really, really fast process. But you do have that cooldown time to deal with. So I can pull parts typically within 2 hours of pulling the build chamber out of the printer. It takes an hour to cool down to the point where you can pull it, and then another hour or two to get down cool enough that you're not going to burn yourself on the parts. Typically.
Oh, cool. Yeah. And then you have that, what is it, sift?
Yep. So the Fuse sift, they call it, and it's got I think it's a 300 micron mesh on just a vibrating screen kind of thing, and it sifts out all the clumps in the powder and everything. It handles all the mixing and dispensing of the fresh and the reclaim powder. So you don't really have to think too much about that. It's pretty nice. They've got this cartridge system that keeps the powder pretty well contained. You're still going to get dust everywhere because that's kind of the nature of it. So like they claim you can put it in an office. I don't know that I would really want to. I would want it probably in its own room within an office at the very least. But yeah, so once you unpack the build chamber, you brush off the parts, and then you typically bead blast them. Or at least that's what I usually do for finishing. A lot of shops that do higher volumes than me have automated blast systems, and I don't have one yet. I would like to get to that point. But yeah, so I blast them by hand currently. I just use Mill 8 media, which is about an 80 grit glass bead, I think. And then I've also been playing with vibratory tumbling. So as an additional post-processing step, if you want the parts to be smoother, I use 3mm porcelain media. So they're just little balls. And ball burnishes the entire surface of the part, and it comes out feeling almost like satiny. It's really, really nice.
Ooh, cool.
Yeah.
And it's sweet. More or less automated. You're not sitting there doing it. So
I do still have to blast first, unfortunately.
Oh, okay.
It's an extra step in the process, but it also helps get like the last little bit of dust off of there because it's a wet process. So it just kind of cleans things up a bit. Yeah. And then for some things, at least for lower volume stuff, we do Cerakote on top. And we use the H series on that, the stuff you actually bake on, because it's a lot more durable. And they have a low temperature cure schedule. So you can bake it like 150 to 180 Fahrenheit, I believe, which is below the glass transition point of nylon. So the parts don't really warp. And the Cerakote kind of gets sucked into the outer skin of the material, which is slightly porous. The parts themselves aren't porous, but like probably the first 0.5 millimeter or so is a little bit. And I've noticed like significant strength increases to the parts as well. They're a lot more durable after that.
Oh, cool.
Yeah.
I had no idea you could Cerakote plastic like that.
Yeah, they come out looking almost injection molded. It's amazing, especially if you get the gloss levels right.
Huh.
It's pretty sweet.
That's super cool.
Yeah.
I had no idea. That's awesome.
Yeah.
You had mentioned SLS versus MJF. Riley Gilman, you answered a lot of his questions already, but he wanted your opinion on SLS versus MJF, pros and cons of both. I imagine you've looked into MJF since you've had such a success with SLS.
I've looked into it. I don't like the consumable cost of the HP stuff and the system cost of it. I mean, it's literally an order of magnitude more than buying a fuse. So like figure an entry level fuse system with just a basic fuse one and a sift and some extra build chambers and all the other stuff. You need a little bit of powder to get started. You're looking at probably $40,000, 40 to 50 by the time you're done, depending on how much stuff you get. And in the One Plus, you add like 8 or 9 to that. An MJF system, you're going to start at about 300.
Right. Yeah.
So
they're so expensive.
The parts are definitely stronger because they have that finishing liquid or whatever it is that helps bind the nylon together. They're a little bit closer to isotropic, but it's such a small difference in practice from what I've seen with MJF parts that I've handled versus the SLS parts that I print that it just doesn't seem worth it to me.
Yeah, that's many fuse ones fully
right.
kitted. So I could see and it seems, at least for me on the outside, it seems like there's no point in buying a fuse one at this point.
Yeah.
Like, I mean, if it's literally double as fast, the extra 10 grand, it seems very well worth it.
Yep. Yeah. The One Plus is fantastic. I had some issues with the first one that I had. I actually had to get an RMA unit because I had multiple full powder cake meltdowns in it. That's in the first like cheap. 200 or 300 hours of running. Yeah. Formlabs was great about it. It took them a little while to finally decide to send me an RMA unit because that's a big process for them. It's a large piece of equipment. I understand why they didn't want to do it immediately. But yeah, I think I had 5 or 6 meltdowns in the first 200 hours, and that's not so good.
No, it's not like, a kilogram of filament for my printer or something. That's expensive.
Yeah, about $600 each time.
Yeah.
But they sent me a bunch of free powder to cover that, which is really nice of them.
Oh, that's great.
Yeah. So they really helped me out. They actually ran some parts for me when I was in a really tight bind. I had some close deadlines to meet and the printer was down and they were like, okay, we'll help you out. We'll do it for just the cost of powder or whatever. And they're like, don't make a habit of this, but if you're in a real bind, we'll help you out kind of thing.
No, that's great. I mean, clearly you've demonstrated that you are a serious customer too. I mean, you have 2 of their machines. It's not like you were, I don't know if I want to buy one yet. Can you run a full batch for me? No. Yeah. So I sidetracked you from your story. You were in a building you didn't want to be in.
Yeah.
And
then
you guys had gotten to the point where you wanted to potentially dissolve the partnership. Where did you go next?
So, we dissolved the partnership. That's the short of it. We didn't see a way for overhead had gotten so out of control at that point with as many people as we had. We needed to be running things more seriously. We didn't have systems in place that we should have. And that's a problem with a lot of small businesses is, I hear people talk about on here all the time is getting those systems in place to streamline things and get everyone on the same page without needing someone breathing down their neck constantly. And our guys were really good. They were very skilled people and they learned really quickly. So we didn't need to babysit them all the time. But still, if you're running a manufacturing operation, you need some kind of organizational system in place. We tried ERPs, we tried all kinds of things. Didn't quite work out for us. Some of that was financial related. I mean, we were running out of money by the end. We were starting to get behind on things. But still, at that point, we had the mini mill, we had a CL1, and all the powder coating stuff. So we decided to sell off the powder coating stuff. I took the machining side of things and I'm like, I'm going to continue the business. So I went around, found a little unit that's in a building that's shared by a bunch of other companies. It's 2,400 square feet, which I realize is not little for a lot of people, but coming from 20,000 to 2,400 is a pretty big jump.
Oh yeah, sure.
So between September and the end of the year, I was able to find this place and move everything in there. My other partners got day jobs. They helped me out when they could. But of course, they needed to make money. And I'm fortunate to be in a situation where my girlfriend and I own our house and we don't have we don't have a very high cost of living. So I can stomach a little bit more risk than my partners could at the time, which is why I really chose to move forward with it. So moving in here, my main goal was to get current on everything again. on all of our past due bills and stuff. So as of January 1st, when I officially took over the company, we were like 90 days behind on a lot of stuff, and it was bad.
Oof, that's rough.
And that was just because there was no cash flow for 3 months, really, when everyone else kind of checked out or had to go get a job kind of thing. And we were working with our creditors and everything, and we were talking them through the whole situation, explaining our position and stuff. And thankfully, that big customer who needed, a couple thousand of those fuse printed parts earlier that summer needed more because their Chinese supplier still had not come through with an order they placed last July for 3,000 pieces. Yeah. So I got the fuses set up in here like the day after I got the keys to the place kind of thing. I had them running as much as I physically could. I was doing about 50 kilograms a month of sintered powder with them for the first few months of the year. Yeah, with 2 printers running each of them about 500 hours a month. It was crazy.
Wow.
And I cranked out those parts, and that work alone got us current again. Just because we had such dramatically lower overhead, and it was just me. I didn't have payroll or anything. And I could just throw all of that money at getting current on all of our loans and our vendors and all that stuff. So as of now, we are current on everything again. And that was a big push to get there.
Yeah, that's a big thing.
Yeah. So then I was looking at it, and I'm like, I really like the fuses because they load their own material. All I have to do is put powder in the hopper, throw some prints, throw some models in it, and hit go. The other equipment I had was not well suited for that. I had a Haas Super Mini Mill, which a single station vise, you can't really do a lot. I mean, it's a capable machine, don't get me wrong. And it did a lot for me over the years. It made really good parts, but it's not suitable for high volume work, especially when there's just one person running things.
Totally, yeah.
It's just not very viable. And then the CL1, it's a cute little lathe. They're kind of funky machines. I liked it a lot, and it had the 6-foot bar feeder on it, which was a mistake.
Well, so maybe let's get into the CL1 just a little bit. Oshin Leahy asked, tell us all the secrets, tips, tricks of the CL1.
So I don't know about secrets, but I would say if you're buying one, don't get the 6-foot bar feeder. I got it because I thought it would be more productive than the 1 meter one. But because of the way Haas builds those bar feeders, it's like $8,000 or $9,000 for this option too. It's a piece of stainless tube with a piston inside of it, and that's it.
Right.
It's literally a piece of aluminum bar stock that they stuck a U-cup seal on and a little live center nose. And that's all you get. It's got a little pressure switch on there. So when the piston goes past the hole in the tube, that's how it sends the end of bar signal. But there is no feedback as to whether it completed a push correctly. And the longer the bar gets, the harder it is to push it reliably. And also the more it whips. There's really no support on it. And because it's going into a 5C spindle, you've got a 1-inch draw tube size. 1-inch ID draw tube. So you can't put a traditional spindle liner in there either. You've got these weird split collars that go in the end of the pusher tube that the end of the pusher nose actually pops out at the end of its throw. And they go flying across the shop. You have to go find them. They usually end up under another machine or something. And that's a whole thing. They're made of Delrin, so if you ever want to run plastic, it will weld itself to the collars because the collars do not rotate with the material. It's just a plain bearing, essentially, on the stock.
So yeah, friction weld.
Yeah,
almost
bad time all around. And if you have the pressure on the pusher low enough that it doesn't distort the stock in the tube, if you're running real long, skinny stuff, it won't push the collars out of the end of the tube. So it'll just keep running in air because it didn't advance any material. The pusher's stuck there, and it's like trying to weld itself to the plastic kind of thing because it's just angry and spinning really fast. Yeah. So it's not reliable for lights out stuff. I did successfully run it overnight a few times with some brass, real simple, like 1/2-inch parts. But it became very clear very quickly that is not what it is good at. I'm not really sure what it excels at, but it is a good little machine. It was decently accurate. Like I could hold better than a thou on it without really any effort. But yeah, very, very limited. And the tooling options for it are even more limited because it's a 1/2-inch shank machine, but it's got one of those stupid platter turrets that are flat, like they put on the TLs as well. Right. So your tool blocks have to come from Haas. And until recently, they didn't actually list them on the website.
Oh, even better.
Yeah. So I was fortunate that when I bought the machine, I'm like, this is going to be a problem. So I bought 2 sets of the tool holders instead of just one. And thankfully, I didn't need to buy any more after that. But yeah, just weird little quirks like that. So if you're running anything over an inch in diameter, like you're using it like a chucker machine, your part can't cross the boundary of the turret because the top surface of the turret is half an inch below center line. So you can run the turret itself into the material without a collision on a tool block or a tool.
Oh, no.
Weird stuff. And then the live tools are mounted on the opposite side of the turret, facing the spindle noses are facing the X positive direction. So you do everything in the X negative side. And that means that if you do the typical G28 U0 W0 to go home between tool changes, the first thing it does is take that live tool unit and go straight into your part.
No.
Yeah, so any default post will not work. You have to go through and at least edit that out. You will crash the machine on every single tool change. It is a huge oversight. I don't know why they did that. And also the live tools are 200 watts.
Oh, okay.
Yeah. 6,000 RPM max. I think the peak torque is at like 2,000 RPM or something, and it's 3 inch-pounds.
Okay, so you've got a hand drill taped to a
less than a hand drill. Yep. So okay. Slotting with 100 thou end mill, I couldn't go deeper than like 30 or 40 thou at a time, or it would stall the spindle. I'd be like, why are these tools breaking? And it just would overload it.
Yeah. Yeah. So there are coolant driven and air driven spindles out there that are more powerful than.
Yep.
Yeah. Okay.
But you also can't get coolant on the turret very easily unless you get a rotary union and mount it to the turret, which we've been talking about a lot in the Discord. Apparently some people have done it. And I think a couple people in the Discord did it recently. But quite a hassle at the very least to get through tool coolant to your tools because the turret doesn't have a supply for it.
Right. Yeah. But then you just recently got a new lathe.
Yes. So one of the things that I did when I realized that, hey, I want machines that load their own material, is I sold off all the Haas stuff because I was pretty tired of Haas. We had a UMC at one point that went terribly, and I can't talk too much about it, but we don't have that anymore. I'll put it that way. And that kind of soured my views of Haas. I never was a huge fan of them, but we got into them because it's what I learned on originally. So I had familiarity with the control. They make it super easy to finance a machine, which was important to us at the time because we were college kids with no credit and no jobs, and they still somehow let us have a machine. Pretty crazy that they do that, honestly.
Oh yeah. Yeah, they are playing the market and hoping that it pays off. Yeah, some of their deals sometimes you're like, wow, okay, so no payments for a year?
Mm-hmm.
Okay, and you're just going to give it to anybody? Okay.
Yeah, I'll take it.
Yeah.
But yeah, so I decided I wanted to get a more serious machine. So at IMTS, actually, I'd been talking with Smart a lot, and they had a really big booth at that show with a lot of machines running live cutting demos and stuff, which is pretty uncommon this past year for some reason. It seemed a lot of the manufacturers weren't actually cutting things, or they didn't have much of a presence at all. Smart was really pushing advertising, and I got talking with a local rep who happened to be at the show. And I was looking at that NL 2000 BSY, which is what I ended up going with. And they cut me an absolute killer deal on it. They import them with the standard option package. So it's kind of like what Yamazen does with the Speedios, where it comes with a conveyor and, the standard coolant system and all the basics you need to get up and running, basically. Full turret worth of tool holders. You get a couple live tools with it and some other stuff. Yeah.
Oh, wow.
Pretty good deal. And it's like 20 to 30% less than the next equivalent Doosan kind of thing, which is really their big competitor. It's a Korean lathe, 8-inch chuck class kind of thing, Y-axis, all the bells and whistles with the sub spindle. And it's a boxway machine. So it's pretty beefy, but it's priced like a Doosan Lynx, which is a linear rail machine. And,
awesome.
pros and cons to each one, but the boxways are going to be more rigid at the end of the day.
For sure.
And they actually don't make a linear guide machine either at Smart.
Interesting.
Yeah, so their lathes are the only things they make in-house currently. They built a factory in Korea a few years ago, and their big focus is these NL series lathes. Their mills, I believe, are white labeled. I don't know who makes them. They're okay. I'm not that excited by them. If I was going to get a mill, I'd probably buy a Speedio at this point.
Fair, yeah.
Yeah, but the lathes are their bread and butter, and I mean, that's why I went with them. I like the idea of a company that focuses on one specific line of machines, where like Haas, they've got a lot of stuff, but like they say, when it comes to lathes, Haas makes a good 3-axis mill.
Well, and especially recently, I mean, this is not knocking Haas, but you look at their new machines coming out and you're like, what engineer did you let loose in the parts warehouse? Like,
oh man, that UMC 350.
Yeah, that or like they had that mill turn was a VTL 750 or
yeah,
whatever that thing was. I don't care who you are. We can all agree that's an abomination that should never see the light of day. I don't know who they made that for, but it's just insane.
Well, I've heard rumors from friends who've worked there before that Gene Haas, the company culture there is they scream at you all day.
Oh boy.
Sounds great. But Gene Haas goes around and just comes up with these ideas and tells the engineers to do them. So it's just throwing ideas at the wall and seeing what sticks.
On one hand, I think it's just god awful sometimes. And on the other hand, I got to applaud them for at least trying. There's not a lot of companies out there that are just like, I don't know, let's make some crazy shit today and see if people like it.
Yeah. I heard rumors of like a dead end project that was a B-axis CL or something, which would
okay.
Sure. I don't know. That will never see the light of day, I'm sure. Yeah, but wouldn't that be so cool?
Right, exactly. Yeah, I'd love to see the pictures still. Like,
Yep. Yeah, and I guess one of their engineers like super tuned a TM1 by anchoring it and putting it on vibration isolators, doing some stuff with the servo tuning, and it was like more accurate than a VF2 or something.
Oh wow, that's super cool. Yeah, see, that's the kind of stuff I got to applaud. Like at least they're trying stuff.
Yeah, it's really cool. And I got to admit, their control is very user friendly. Coming from Haas to Fanuc has been a bit of an adjustment. And I'd only ever used old Fanuc, like the Fanuc O-Mate, the community college kind of thing. And I had a Romy Center 35E at one point that I picked up off of Facebook Marketplace. It was from 1992. It's a tool room style lathe. So it's like an engine lathe. It's a flatbed, not a slant bed, with a turret on it. And it had a Fanuc OTC on it from 1992 and drip feed only kind of thing. And it was miserable. The keypad was all faded and didn't work half the time. Like you press a button and it wouldn't register. So that was kind of my impression that Fanuc going into this. But new Fanuc's nice. It's very usable, I've found. I mean, it's not pretty, I don't think. This does have the fancy Fanuc overlay screen kind of thing, their new HMI or whatever it is. I don't use that. I use the maintenance display because it shows more information. But yeah, I like it so far. It's very reliable. It does exactly what you tell it.
Awesome. Good. So you're making parts already on it?
Yeah. Yep. Awesome. It's not running right now because I didn't want the background noise. But
yeah, appreciate it.
Yeah. Yeah, no, got the bar feeder installed on it. What's that? A week and a half ago, I guess they finished that up. It's an IMCA Kit 80. Pretty standard bar loader from what I understand. The HMI on that is awful. My God, I don't know why bar feeder controls are so terrible, but it's one of those Siemens touchscreen HMIs, and like all the graphics on it look like they're from about 2003.
Lovely.
It's all translated from Italian, and I guess Italian to English doesn't really work that well, at least for industrial stuff. So the error message you get are pretty wild.
Yeah, I'm sure. I mean, I'm literally wearing my cancel with saving changes shirt from Henry Holsters today. So I know all about weird translations into English. But yeah, this is a great time. It brings us on to shop news and new things. Besides the new lathe, anything else new or exciting in your world?
It's really been the lathe at this point. I mean, the rest of my time has been just kind of organizing the shop and unpacking things and getting everything all sorted out in here. You can't really see that much behind me, but you can see that it's a disaster in here.
Historically, it looks like you're freshly moved. Yeah.
Yeah. I mean, it's only been 7 months at this point.
But 7 months when you're busy is like, no time at all.
Yep.
So I totally understand.
Yeah. I mean, it's been me and my intern, Ethan, who's been a huge help. He's still in college at RPI. He was running our little anodizing line at the old building and got really, really into it, was doing a whole bunch of cool decorative stuff and wants to keep doing that. So I told him, come help out in the summer. We'll get the anodizing line back up and running and everything. And we'll have that as a service as well. Because I like to do small batch finishing. I don't want to do like super high volume commercial stuff. It's really expensive.
I think there's a big hole in the market for that too, of like high quality, quick turnaround finishing. I keep trying to improve. Like my anodizer is fantastic. Mm-hmm. I really love them, but I keep telling them, I'm like, listen, I will pay you double lot fees no, like as my base,
Uh-huh.
as long as I can come in and give you rush parts and they come back when I need them. And like you give them attention to detail. I was like, I will do this every time. Like I will be your highest profit customer if you can do this. And it's slowly, I think, starting to sink in that like, oh, okay, there's this market for like, no BS, just get it done tomorrow kind of stuff.
Yep. Yeah, there are not very many anodizing houses in my area, unfortunately. Like we're in the Albany area of New York, and there's a bunch of stuff up by like Rochester, Buffalo area, but that's a few hours away at least. And then there's like Connecticut anodizing, which is huge. I mean, I'm sure you've seen them on Instagram. They're one of the bigger ones in this region, but they're booked solid and they're super expensive too. But yeah, there's no one really local to us, and that's kind of why we got into it. We'd worked with some other local anodizers that were within like a hour radius of us. One of them was they made turbo impellers primarily, and they just happened to start anodizing for their own in-house products kind of thing and built it into a process they offer. But they screwed up a whole bunch of parts for us a couple of times, and they redid them. But one of the jobs they couldn't redo because it was hard ano on Mike 6 plate, and because it's porous, you can't strip it very reliably, or they wouldn't strip it or something. It was a whole nightmare, and we're like, we can't keep dealing with these companies ruining our parts. We tried someone else; they ruined another batch of parts, and like that seems to be a common theme with anodizers. I don't know what the deal is. So we put together a little system with like a 60 amp lab power supply kind of thing that I found on eBay, some little tanks and pumps and stuff like that, and we've been getting really good results. It works really well.
It's awesome. Yeah.
So
I think it's if you have the room and the know-how, I think it doesn't sound like it's exceptionally hard to anodize well. What I've been told, like one of my jobs had a giant lot of really expensive parts scrapped out by a coating house, and I think it was the VP or something came down to the company and was like, listen, like, I'm so sorry. These guys will move job to job for 25 cents more an hour. All of these coating processes are a very low value add for us. Like it might be $100,000 in parts for you, but it's $100 process for us. Mm-hmm. And so it's like, it just doesn't get the attention it needs, I think is what really it ends up being, unfortunately.
Yep. Yeah. I mean, that's the case with a lot of finishing companies for whatever reason. It just seems like they just don't have that attention to detail. I think you're right. It's because of those small minimum lots. It just makes it really hard. But anodizing is just about process control. Like if you can handle process control in any other kind of industry, you can probably do it with anodizing. It's really just following the instructions kind of thing. And the information's all out there. I mean, there's a bunch of good books on it. There's a lot of online resources, and it's really not that hard to do. But yeah, you do need good fume extraction and containment and stuff like that. And that's the big limitation for most shops. We're still trying to figure that out here, which is why I don't have it set up yet.
Right. Yeah, exactly. Yeah, that is the scary part of it.
Yeah.
Well, that brings me to one of two questions I ask every guest every week. First of which is, what did you research this week? Doesn't have to be machining related, doesn't have to be your new lathe related, just what's been popping up in your browser that's interesting.
See, I knew this was coming. I couldn't find a good answer for it. But yes, broadly, I've been trying to go back and learn a lot of the math that didn't really sink in for me in college. I didn't really have a great foundation in math going into engineering school. And that, I think, was something that I really struggled with, especially in those earlier classes where, they're trying to weed you out kind of thing. And I'm encountering problems now that you actually need calculus for, like differential equations and things like that. It turns out they describe most things in this world.
I find that all of those classes do such a poor job of connecting with students. Like,
yes,
they'll give you like game warden examples for differential equations. It's like, dude, you have car nerds and like, manufacturing people in your classes.
Right.
Make a more tailored example, like, and you'll get buy-in. You'll get, oh, this is why I need to do that. Because I'm the same way. I went through all the way up through Calc 3 and I have retained almost none of it. And then I have started now like, oh, I could use DiffyQ for that. I wish I remembered it because that would be really helpful right now.
Yeah. I used to be really into electronics too, especially in like elementary, middle school and stuff. Like I found some electronics books at the library when I was a really little kid and happened to have a soldering iron. So I started putting things together. kind of
That's
got
awesome.
out of it in high school. But honestly, if I'd kept up with it, I probably would have done an EE degree instead. And I kind of wish I had, because it really seems like the way electrical engineering is taught at most colleges gives you that kind of hands-on experience that you need to connect those concepts, where like with mechanical engineering and stuff, it's all physical objects and you can see what they're doing. But with the electrical engineering labs, they can demonstrate really complex systems with pretty much the same set of parts, just in different configurations, kind of thing. And you can do it, almost all of it, with a breadboard and very little other equipment. So it's really easy to put together labs for that kind of thing compared to like, physics concepts for mechanics kind of thing, where a lot of those objects need to be quite large or moving at high velocities or whatever. You can't see the electrons, but you can at least measure what you're doing with standard equipment really easily. And,
right.
there's a direct analog for all of the physics equations that you use for mechanics in electrical engineering. It's almost the same equations, just with different letters, basically, and different
Right.
constants. So I feel like if you go to school for an EE degree, you wind up much better prepared for any kind of hands-on engineering. And most of the really capable project engineers I've met who can turn out prototypes on their own and do complex design build projects really, really quickly, they almost all did electrical engineering degrees.
Interesting.
Yeah.
Huh.
So I'm trying to learn some of that stuff too, kind of catch up with what's changed since like 2008, which turns out there's a lot. Yeah. And just kind of refreshing, like just the very basics of electrical engineering before I get into more like signals and systems and things like that. But the more complex topics with where you actually need the Diffie-Q and all that stuff for like waveform analysis and things like that. So yeah, that's been in my Google searches quite a lot lately.
Okay. So the last question I ask is, what are the things you're working on to be a better person, leader, employer, what have you?
So the big thing for me has been getting systems in place, and I'm still working on that. It's hard, as you know. It takes a ton of time and dedicated effort to build systems that are effective, that you want to work with for a long period of time. It's kind of nice that I don't really have to worry about a full staff at the same time. So I can kind of just play around with stuff and not have to commit too hard to any particular system until I see it works well. But like I got set up with Digifabster earlier this year for quoting for specifically the SLS printing. And it's been fairly successful so far. I like it a lot. I'm trying to simplify a lot of the administrative tasks so that I can focus more on that kind of operations management stuff and get to the point where I'm ready to hire someone. So in terms of like personal growth in that sense, I mean, like I said, I'm not very organized. So
I can empathize for sure.
Yeah. I mean, I think almost everyone who's been on this podcast has some form of ADHD or something. So it can be hard to overcome that. I mean, I've worked really hard on that aspect of myself since I realized that I have ADHD in college. It's been a long path, but I can confidently say that I have made a whole lot of improvement, even just in the past 6 months. But really, since I started the shop, that personal growth trajectory has only been up in terms of how confident I am in my abilities as a business owner and as a machinist and everything, just because I can finally see the pieces kind of fitting together in my brain. Like I'm filling in those little gaps, and it's letting me kind of push a lot of the business stuff in the background. I can do it automatically now. I don't have to think about it. And the less stuff you have to think about, the more efficient you can be.
Totally. Yeah. Completely agree. I think that very often, I don't know how to word it, but like those are the things that it's really hard to focus on. But like once you get them done, it's like game changing.
Yep. Yeah. Like every morning I go into QuickBooks and I reconcile all the accounts and everything. And it's a routine now. It's great. It feels good to have everything categorized properly. And like QuickBooks kind of gives you the little graphics and stuff when you have everything in an account reconciled. So like you see that and you're like, ooh, I'm 100% reconciled. That's pretty sweet.
That's awesome.
It's really good motivation, like little breadcrumbs kind of to keep you going. Because if you don't keep up with that, as you know, it piles up quickly.
It sure does.
Yeah, reconciling the books after the split was challenging because my one partner had been handling all the financial side of things for about almost 5 years in business.
Yes.
Yeah. And, we started off, didn't really know what we were doing. So there was loose ends from the very beginning, not too many. And we had good accountants, but there was poor communication with them. So things hadn't been reconciled since like last June, at least completely. Yeah, so catching up on 6 months of books with a whole bunch of entries where it just said a check number with no image. And I'm like, cool, who'd this come from? Where's it going to? What's going on here?
Oh, no.
But
Yeah.
that took a little while. We're in a better place with that now. So still a little bit left to tie up, but it's mostly done. Yeah. Yeah, I would say that was the biggest hurdle to overcome from that transition was just the financials and getting the books all cleaned up.
I'm sure. Yeah. Especially when somebody else has their own kind of shorthand, like
Right.
they've developed how this is all going, and then you're like, it's like running somebody else's program, CNC program. You're like, what are you doing? What the hell is this?
And this is a disaster. Oh my God. Yeah.
I guess that worked, but that's not how I would do it. Like, yeah, I can totally see that.
Mm-hmm.
Boy. Well, Brad, thank you so much for coming on the podcast. I
Yes,
really
thanks for
appreciate
having
it.
me.
It was, we've talked over Discord and stuff, but it was really nice to put a face to the name and really get to know you more.
Thanks. I appreciate it.
And thank you to all the Patreon members who make this show possible. I was able to send Brad a mic and headphones so you guys have good audio. Thank you all for listening, and I will be back next week.